Hi everyone. In last class, we have discussed regarding control system, that is module 3 question. Okay. We have discussed the type 0, type 1 and type 2 order. Right. Steady state error concept we have discussed. Today, the question is like this: check the stability of the given characteristic equation using average criteria. So s to the power 6 plus 2 s to the power 5 plus 8 s to the power 4 plus 12 s to the power 3 plus 20 s square plus 16 s plus 16 equals to 0. This is the question. It is given in the question paper also. Now we shall see the solution of that question. They have asked you to check the stability of that equation. Okay. Using what? Using average criteria. Okay. This is a question. Check the stability of the given characteristic equation using root method or using average criteria. This is the question what they are given. Right? So first we need to substitute here A naught, and so this is A naught and this is A2 and this is A4 and this is A6. So here this is the value of A1, A2, A3, A4, A5, A6, A7. Okay. So A to the power of, this is constant. What we will substitute in the s to the power of 0, there AN, that is the final value. Okay. So now even numbers first row and next row is odd numbers. So A1, this value is A1 and this value is A3 and this is finally A5. Okay. Here s to the power of n. So n value is here 6. So s to the power of 6. Next step is s to the power of n minus 1. So the value is 5. Okay. Again n minus 2, s to the power of 4. You go on decreasing s to the power of 4, s to the power of 3 and s to the power of 2 and s to the power of 0, like that. Okay. So now here A1 into A2 minus A3 into A0. That is the value of here. Okay. This is nothing but over, it is a B1 value. Okay. This is nothing but B1. So in order to find B1, so what you need to multiply? A1 into A2 So A1 into A2 and A0 into A3, A1 into A2 minus A3 into A0 divided by A1 only. So for B2, this is the value of B2. Okay, this is a B2. For B2, A1 into A4 minus A5 into A0 divided by A1. So you can observe 2 into 20 minus 16 into 1 divided by 2. The value is 12. Okay. Similarly, A1 into A6 minus here 0 into A0. That is 2 into 16 minus 0 divided by 2. We'll get the value is 16. Okay. Next, s to the power of 3. Here we got the value 2. So 2 into 12, okay, this one, 2 into 12 minus 12 into 2 divided by 2. So 2 into 12 minus 12 into 2 divided by 2. Okay. So this is B1, B2, and here is B3 value. So in order to find C1, here this is the C1. Okay. In order to find C1, what you need to multiply? B1 into A3 minus B2 into A1 divided by B1. That is what we have done here. Right. Next step is C2 here. Okay. So to find the C2 value, what you need to multiply? B1 into A5 minus B3 into A1 divided by B1 only. Okay. So here the row is totally 0. Okay. This overall row is 0. This is the special case 2. Okay. So special case 2 means that is overall element 0. Okay. Overall row is 0. So only one part, only one element is 0, then we can replace it as epsilon. Okay. If overall row is 0, then we need to take before that what equation is there? S to the power of 4. Okay. So for s to the power of 3 line, 3 row, we got 0. So before that, what it is saying? A of s equals to 2s to the power of 4, okay, and 12s to the power of 2 plus 16 equals to 0. This you differentiate 2 into 4 into s to the power of 3. So what you will get? 8s cubed. 12 into 2 into s, that is 24s. When you differentiate, you will get 0 this one. Okay. Next, after solving this, so instead of writing s to the power of 0 here, overall row is 0. So here you need to write 8 and here you need to write 24. Okay. So as it is, these both what you have written before. Okay. This will not change. This is also same as it is. Where we got this as 0, there you replace 8 and 24. Next you continue 8 into 12, okay, minus 24 into 2. 8 into 12 minus 24 into 2 divided by 8, you will get 6. Next 8 into 16 minus 0 into 2 divided by 8, you will get 16. Next 6 into 24. This is 6 into 24 minus 16 into 8. Okay. Divided by 6. So what you get? 2.67. Next value is AN value. What it is the final value? That is 16. Okay. So it is in the question only 16. You can observe here. Okay, this is 16 final value that you need to substitute in the s to the power of 0. Okay, so no sign change. So system may be stable. So whether if you observe in the first column, okay, first column, always you need to check in the first column. Okay, so this is value is positive, this is also positive, and this everything is first column is positive. So what? No sign change, so system may be stable, but as there is a row of 0, what we get before is row of 0. That's why the system may be a marginally stable or it may be a unstable. So in order to examine, in order to determine whether it is a marginally stable or it is a unstable, so we need to make that a of s equals to 0. Okay. So before what we have taken 2s to the power of 4 plus 12s to the power of 2 plus 16 equals to 0. We cannot find out like this s to the power of 4. Okay, it is difficult to find out the roots, right? So you can replace s to the power of 2 equals to y. Okay, so it will be easy to find out the roots. S square equals to, you can take it as y. So what it will become? 2 into y square plus 12y plus 16. You can find in the calculator, right? So s square equals to y square plus 6y plus 8 equals to 0. y equals to what you'll get the roots is -4 and -2. You can solve by this method or you can solve by calci. If you solve by this method, that is minus b plus or minus square root of d square minus 4ac divided by this is whole divided 2a. Okay, this is whole divided by 2a it is. So now we know the roots of y, -4, -2. But what is the value of y we have taken? S square. So s square equals to -2 and s square equals to -4. S equals to plus or minus j square root of 2 and s equals to plus or minus j into 2. Okay. So here the square root of 2 value is 1.41. That is non-repeated roots here. You can observe here, right? So this is j omega axis and this is real axis. Okay, real part axis. So j omega 2 j 1.41 and minus j 1.41 minus j2. So it is a non-repeated roots on the imaginary axis. So hence the system is marginally stable. If it is a repeated roots, okay, if it is a repeated roots, that is j2 j2 j minus j2 minus j2, then we call it as a repeated roots. If repeated roots is there, it is a unstable. If it is a non-repeated roots is there, then we call it as a marginally stable. In next class we shall discuss with the other topics.